Maybe the best way to tell you what it is with a problem, okay? Oh man, Nate Engage, that's from like many years ago. I update that sheet every year with new names. This is year 4. Yes. It was when I graduated college. Got to start somewhere. It was weird when I taught seniors because I was like a couple years old, you know. But that's not the case anymore. Anyways, Nate and Gage decided that they really want to buy a new Tesla. They pool their resources. They're out buy a Tesla for 77 grand. Say the car depreciates at 6%. And then it asks this, how many years will the car be worth $20,000? Okay, so there's a little bit of recap from what we were doing earlier. Which equation do you need to use here? Are you using PERT? No. Why not? You're not talking about interest, right? So you're not using PERT. You're also not using the other interest equation, right, with the n in it. So which one are you using? It's just exponential growth or decay. Is it growth or decay? It's decay. So the equation there is this. That's the equation for exponential decay. Let's get all of our pieces. You got an initial amount. It's 77. What else do we have? We have the rate. And what does this statement give us? Yeah, that gives me the final amount, right? So here's A, here's Y, and here's R. So I have 20,000 equals 77,000 times 1 minus, rate got turned into a decimal, right? So what's the decimal going to be? 0.06 to the T. If we simplify that a little bit, 20,000 equals 77,000. What's that, 0.94? 0.94 to the T. What am I trying to find? Time. I want to know how many years is it going to take. So what would you do? How do you solve for T? Well, it's getting multiplied, right? So I'd have to divide, I'd have to divide 77,000. Got to divide 77,000. That's some decimal. What's 20,000 divided by 77,000? Good enough for our purposes. So I have that decimal equals 0.94 to the T. This is where we run into a problem. How are you going to get T? A root of T? What is that? Like, do we even know how to do that? And even if you take if you take a teeth root, if you take a T root, that gets rid of the T, right? And you don't want to get rid of the T. You want to solve for T. Well, it's 0.94 raised to the T power. So this is the problem. Like, we get here and we're like, what do you do? We don't know. We don't have an operation to do this. You don't know. And that's the problem, okay? This is where logarithms come in. We have to use something called a logarithm in order to find this, all right? So sometime way back in the day, some math person was doing math, because back in the day, math people got paid a lot of money to just sit around and do math, you know? Actually, not that far. Just before computers. Anybody ever seen the movie Hidden Figures? Yeah. People got paid like a lot of money literally just to do math, you know? Well, yeah, I mean, it's, yeah, part of the movie, but yes. Anyways, You don't know how to do this, so we need this thing called a logarithm, okay? Let me tell you what a logarithm is. There's going to be a lot of stuff on this slide. You don't need to write all of it down. It'll get posted if you need it. Whoa. Logarithm. This is how we write it, okay? Here's how you say this. This is how you would say this. Log base b of y. Log base b of y equals x, all right? It's a function. A logarithm is just a type of function, but the question that kids always ask me is like, I see that you write it down, whatever, but like, what is it? What is a logarithm? All it is a question. That's kind of the simplest way I can put it. A logarithm is just something that's asking you a question. And the question is this: what power do I need to raise b to in order to get y? And the answer to that question is x, okay? What power do you need to raise b to in order to get y? That's what logarithm asks you, okay? Do you guys remember when we talked about inverse functions? Like a couple weeks ago? Like the opposites, it's when you had to switch x and y and solve them, you just like flip-flop an equation. A logarithm is the inverse of an exponential function, okay? So every logarithm has an equivalent exponential form, and there's a way that we can switch from one to the other, okay? So let's talk about that for a moment. So let's say you have the exponential form y equals b to the x, okay? To change that to a logarithm, all you got to do is take the base of the exponential and move it to the other side, and then it becomes the base of a logarithm. So I start here, I move it over, and it becomes log base b of y. And we're going to do a ton of examples of these, so if it seems weird right now, don't sweat it too much. We're going to do a bunch of them. Just to kind of solidify a little bit what a logarithm is, look at this thing right here. How do you say this? Log base 2 of 16. And it's asking the question, what power do you need to raise 2 to in order to get 16? Well, what do you need to raise 2 to get 16? 4. So that's why it's 4. Does that make sense? That's what a logarithm is. It's just asking you a question. It's the inverse form of this exponential expression. 2 to the 4th is 16, right? We know that 2 to the 4th is 16. You can write that as a log just by taking the base over and turning it into a logarithm, okay? Why don't we just do some examples of this, and hopefully it'll kind of make it feel a little bit easier, okay? It says rewrite the equation in exponential form. So I have a log, and I want to rewrite it as an exponent. It says 3 equals log base 6 of 216. Or that's asking you the question, what power do you need to raise 6 to get 216? The answer is 3. But we can move it back and forth from a log to an exponent. That's what we're trying to figure out right now. All I need to do is take the base of the log, move it over to the other side, okay? And since it's a log right now, it's going to turn into an exponential, right? The log is going to be gone. Like, it's not a log turning into a log, it's a log turning into an exponential. Okay? What I'm trying to say is that the log's gone now. You don't need to write log over here because it's gone. So here's how I think about it. I take the base, I move it over here. It's like I'm jamming it up underneath the 3. So now it's 6 to the 3rd power. The log is gone now because I moved it. It's done. It's not a log anymore. So what's left over? 216. 6 to the third power is 216, okay? Did that make a little bit of sense? Teeny bit. It's just a matter of moving numbers back and forth. Let's do one more. We'll go the other way. This one was going from log to exponent. Now this one gives me an exponent and tells me to turn it into a log. Same thing. All you got to do is move the base over to the other side. So what's the base? 9. 9 is the base of this exponential. So I take the base, I move it over to the other side, and it's going to turn into a log, right? What's left over here? 2 equals. The base over here is the base over here. So it's log base 9 of 81. And that's it. We know that 9 squared is 81. And in log form, this is asking you what power do you need to raise 9 to in order to get 81? And the answer is 2. You guys picking this up a little bit? It might seem really abstract, and that's because it is, kind of. It's kind of weird. It's kind of a weird concept. But we have to have this inverse exponential in order to answer questions like this, right? Because in order to do this, I need a log. What power do you need to raise 0.942 to get this? I don't know. I need a log in order to help me do that, okay? But we'll get to those problems here in a minute. How about for now, just practice moving from log to exponential and vice versa, okay? So these ones are logs. Try to turn them into exponents. These ones are exponents. Try to turn them into logs. It's just a matter of moving the base back and forth, all right? So try to get some practice with that. Okay, here we go. Evaluate the logarithm. Here's what that means. So logarithm's asking you a question, right? When it says evaluate the log, that just means answer the question. So what is this asking you? What power do you need to raise 4 to get 64? 3? 4 to the third power? Okay, so it's 3. Unbelievable. That's all it means, okay? This one is kind of goofy. What power do you need to raise 36 to get 6? Whoa, 1/2. Why? Yeah. What's 1/2 power? It's a square root, right? It's a square root. So 6 is the square root of 36. So it's 1/2. Yeah. There's another way that you can think about this if it is kind of tripping you up a little bit. You could, if you wanted to, turn it into an equation. I don't know what the answer to the question is. Well, let's turn it into an exponential. Now it's 64 equals 4 to the x. It's just another way of looking at it, right? 4 to the what power is 64? Well, it's 3. All right, so x equals 3. Same thing. So this is kind of doing it in your head. If you need to write it out, go ahead and write it out. Let's see. Try those on your own. Answer the question. What power do you need to raise that number 2 to get the other number? What about D? D is similar to B. What power do you need to raise 27 to get 3? 1/3, because the cube root, why does that happen? I don't know. The cube root of 27 is 3. You can write that as a 1/3 power. So the power you need to raise 27 to get 3 is 1/3. Okay? Are you feeling all right about this? If it seems goofy right now, it's okay. We're going to practice it a lot. All right? Okay, I got to show you a couple more things here. We got about half an hour, so we're good on time. A couple things, and then you'll be on your own. There are two like special kind of logarithms that we need to know about, okay? One's called the common log and one is called the natural log. If you look on your I don't have a picture of it, but on your calculator, probably not on the phone. I don't think the phone has this. I think we've reached the point where your phone is obsolete. I don't think it has a log button. Maybe it does. I can't remember. You got a log button? Do you have an LN? You do? Oh, cool. All right. Cool. Yeah, yeah. Okay. So on your calculator, you have a button that says log. All right. Here's what that is. It's the common logarithm. That's a logarithm with a base of 10. So it looks like this, log base 10. Okay. The natural logarithm is a logarithm with a base of, there's that number again, E. The VIP Baller Club, E. Yeah, that's okay. That's all right. Yeah, it's okay. So here's kind of what you need to see. The common log is log base 10, all right? Mathematicians are all about not writing as much as we need to, okay? We're all about abbreviating stuff. So log base 10 comes up a lot. So from here on out, we're going to write log with a base of 10 just as log with no base, okay? So if you see a log with no base written, that means that it has a base of 10, and it's just what we call the common log. So in your calculator, the log button is a log with a base of 10, okay? So just understand that. It's a log with a base of 10. We just don't write it all the time. Same thing with the natural log. Log base E comes up a fair amount, all right? So instead of writing log with a base of E, someone way back in the day just decided, hey, let's call that the natural log, the natural logarithm. And then they got even more freaky and said, I know I just said let's call it the natural log, but let's write it ln, not nl, you know? What'd you say? Probably. It's probably Latin or something, or Greek, I don't know. ln. So anytime you see ln of x, that is a log with a base of e, okay? Anytime you see log with no base, that's a log with a base of 10, okay? So let me just show you a quick thing with this, just to drive it home a little bit. To convert each log to an exponential, well, we got to know what we're looking at here. It says log of 5. There's no base written. What is the base of that? It's 10. If there's not a base written, it's 10. Yeah. Yes. If the base is not 10 or e, they'll have a number there. Okay? So there's no base. So I know that this is a 10 down here. We just don't write it. So if I want to turn it into an exponential, what number am I moving? I'm moving 10. I got to move the base, right? So it's 5 equals 10 to the y. Guys, so if you see a log that doesn't have a base written, it has a base of 10, we just abbreviate it, okay? It's kind of like if you see an x, you know that it has a 1 in front of it, we just don't write it, all right? Okay, so that's the common log. Let's do one with ln. ln of 6, there's no base written, but what do you know the base to be? It's e, right? If you see ln, it has a base of e. So if I'm going to move it into an exponential, what number am I moving? I'm moving e, because technically this is log base e of 6. So I got to move the e over, and that's what we got. See what I mean? Just for like a minute. This should not take very long. Try those two right there. Just to solidify it. Should not take us very long.